Number 5, we're given this function, and we're first asked to show that the derivative can be expressed like this. So let's take the derivative and do some algebra. So let's take the derivative, f prime of x. It's going to be a product rule. It's the derivative of x to the 2/5 times x squared minus 6 plus the derivative of x squared minus 6 times x to the 2/5. Alright, these are just going to be power rule. It's going to be 2/5 x to the 2/5 minus 1. We want to be careful to do this right. And then this is just from the product rule. Derivative of x squared is 2x. Derivative of 6 is 0. So this side I just get 2x times x to the 2/5. Okay, so 2/5 minus 1, that's 2/5 minus 5/5. This exponent is going to become minus 3/5. So that's what's going to be there. And so to simplify, I'm going to drop that into the denominator along with this 5 that's in the denominator, and then the 2 and the x squared minus 6 will still be in the numerator. So I'm going to drop the 5 in the denominator. It's already there, but it's going to, of this entire term. And then I'm going to put that in the denominator. The second term, I'm going to add the exponents. This is going to be 1 plus 2/5. When I multiply these together, well, that's 5/5 plus 2/5. That's going to be x to the 7/5. Now you can see what I have to do is I have to combine them as a single fraction. I'm not sure why that parentheses is there, but ignore that. But then need 5x to the 3/2. That means I need to multiply this one by 5x to the 3/2 to get that common denominator, divided by 5x to the 3/2. That'll give me a common denominator. So here I'm going to just go ahead and multiply this out because we're going to have to combine things. So here's what I have in my first term with that denominator. And now my second term is going to have that denominator. And here's what I get. I get 2 times 5, there's 10. 7/5, x to the 7/5, x to the 3/5. When you add those, you get x to the 10/5, which is x squared. So combining these, I got 2x squared minus 12 plus 10x squared, because 10/5 is squared. Or 10/5 reduces to 2, I should say. Okay, so combining these, I'm going to get 12x squareds. Go down a little here. I get 12 x squared minus 12. In the bottom I got 5x to the 3/2. Factoring out the 12, I get what's up there. And I should have gone a little farther. I'll need to do that in the next part of the problem. Is this I can factor that, so might as well factor it. X minus 1, x plus 1. I'll probably rewrite this problem, getting rid of that parentheses over there, but I'll go ahead and rewrite it so that it's clear. It needs to be factored completely. I should have done that. But, so we get there. We get this. That's your simplified form, which is what this can be written as. And I need that, it turns out, in part B, because it says now use what you just came up with to find all the critical points. But remember, your critical points come from where f prime equals 0 or f prime does not exist. Well, I can just look at this and tell you where f prime is 0. That's where the numerator is 0. That's at x equal 1 and minus 1. I have 1 from here, minus 1 from here. And f prime doesn't exist is where the denominator is 0, yet, and so any x's that make the denominator 0, yet your original function still makes sense at that value. Well, when x is 0, we're going to get 0 in the denominator, and x equals 0 is okay here. You can plug it in, it's defined. So if x equals 0 wasn't okay here, then I wouldn't include it, but it is. So I get x equals 0, so that's my critical points. And that was all the work, obviously, was done in getting to this form, but then we can use it to talk about where we have these points that are going to be the interesting points that we'll use then to sketch graphs and do other things.